Okay, students. Now, let's say there is a wall. Okay. Now, an object is coming and striking the wall at an angle of inclination. What is this line? The line which I've drawn with green ink. What is it? Normal to the plane. Normal to the wall. Let us say this line makes an angle alpha with the normal to the plane or the wall. The ball is moving like this and hitting the wall, and it's going to get reflected back. Or in other words, rebound. It is going to be rebound. Just like you might have learned in considered optics, just like a ray of light strikes the surface and reflects back, and it will make equal angle of incidence equal to angle of reflection, like that. This ball is striking the wall and coming back, okay, in this direction. Now, we need to find out the change in momentum of this ball, okay? Now, tell me, guys. So, mass of the ball is m, and it is moving with velocity v in this direction, which I have shown. Let me call it as v1. Or let's say v itself, okay? It is rebounding with the same magnitude. That means the speed of the ball is same, but direction has changed or not? Has changed, right? So now we are interested. If direction has changed, can I say velocity has changed? Yes. Velocity is a vector. So whether magnitude changes or direction changes, I say velocity has changed. So velocity has changed now. Has momentum changed? Yes. If velocity has changed, momentum has also changed. Now, if momentum has changed, then there will be a force that we can find, right? Force of impact. So what is it? External force will be equal to what? dP by dt. Change in momentum by change in time. So we need to find the initial momentum of the ball and the final momentum of the ball. Here, it is not so straightforward. Is that clear? So what do you do? Please observe carefully. I am extending this vector, that v vector I am extending, so that I will be able to resolve into components. All of you might have learned in motion in a plane chapter, projectile motion, correct? In that, if you remember, if I throw the ball or an object projectile like this, with an angle inclined with 30 theta with the horizontal, then what will happen? This velocity vector can be resolved into two components. One is a horizontal component, another one is a vertical component. So this one will be what? U cos theta, and this one will be what? Depends on theta. So whichever side is touching theta, that will be cos, and the other one will be sine. You might have learned. We are going to do that. Come on, tell me, students. If this angle is alpha, what is this angle which I have drawn? Alpha. How? Vertically opposite angles. Good. If this is V and this is alpha, correct? Then you can resolve it into two components. This velocity vector can be resolved into one component along the x-axis, another component along the y-axis. So we are going to do that. Yeah. So the one which is horizontal, what is it going to be? V cos alpha. What is the other one? V sin alpha. Now similarly, I have, this is for the incoming momentum, incoming ball. Now the ball which has a rebound, for that I am going to draw. I am going to solve the vectors for this. This is the reflected work vector. I am going to resolve it into how many components? 2 components. So already angle is there for you. It is alpha. So I'll resolve it in 2 components. One is horizontal, one is vertical. I'll do it with black ink. So this vector can be resolved into 2 components like this. This is V. So what is this component? Come on, tell me. V cos alpha. What is this? V sin alpha. Very good. All right, guys. Now I am going to write vector notation. What is I cap? You might have learned in second chapter, motion in a plane. What is I cap? What is I cap? Come on. Unit vector along x-axis. What is j cap? Unit vector along y-axis. So how will I write these vectors? Let me tell you. Now the incoming vector. Velocity I vector. This is my initial vector. Now what is the x component, guys? What component is along x-axis? Come on, tell me. V cos alpha. So it will be V cos alpha along which axis, guys? X-axis, negative or positive? Negative x-axis. Left side, V cos alpha. The colored one. Negative x-axis. So it is what? Plus I cap or minus I cap? Minus I cap. Plus. Now, what is the other component of this vector? Come on. V sin alpha. It is along which axis? Y-axis. Positive y-axis, negative y-axis. Negative y-axis. So minus j cap. Very good. Now we have written velocity, the incoming velocity. Now we'll talk about the outgoing velocity, which is the reflected ball. The final we'll talk about. Now V final has how many components, guys? Black, V sin alpha and V cos alpha. V cos alpha is along which axis? X-axis, positive x-axis, negative x-axis. Then plus I cap, minus I cap. Plus I cap. What about V sin alpha? Y-axis or x-axis? Y-axis. Negative y-axis, positive y-axis. Negative y-axis. Minus j cap, plus j cap. Clear, guys? Yes. Now, I want to find the change in velocity. I want to find the change in velocity. What is change in velocity, students? Final velocity minus initial velocity. So you have to subtract 2 minus 1 or 1 minus 2. Second equation minus first equation or first equation minus second equation. Second equation minus first equation. So tell me, guys, V cos alpha I cap minus of V cos alpha minus I cap, what it will become? Minus or minus will become plus. So V cos alpha I cap plus V cos alpha I cap. What do you get? 2V cos alpha I cap. When you subtract minus V sin alpha and minus V sin alpha, what will you get? 0. So V sin alpha component gets cancelled when you subtract it. So you get what? 0. So this is your the expression for your final velocity vector. Magnitude, if you take, what will be the magnitude, students? It will be only what? 2V cos alpha. Clear to you? Why is the magnitude? We are not having I cap. What is the magnitude of I cap? 1, because it is a unit vector. Good. Take this down, then we'll go back to slide. Because it is not explained in that detail in my slide. Vector resolution is an important concept to be made thorough in motion in the plane itself. I'll repeat once more. Okay, the whole thing. Meanwhile, you can take down. We have the ball coming here, hitting the wall at an angle of what? Alpha. So the velocity is vi. You extend it here so that you are able to plot it. This angle is alpha, means this angle also will be alpha because it is alternate angles. Not alternate. Is it alternate angles? No. Vertically opposite angles, I'm sorry. Right. Okay, then come on, guys. This ball hits the surface and comes back like this. Here also it makes an angle alpha. Now this vector is initial vector. This is the final vector. Final minus initial is your change in velocity. So initial velocity can be resolved into two components. One is your cos component. Another one is what? Sin component. This comes from simple trigonometry. You would have done it in projectile motion itself. U vector is there. You call this as what? U cos theta. What is this? U sin theta, vertical component, right? Same. So here it is V cos theta, cos alpha. Here V sin alpha. But negative x direction, so minus I cap. I cap is the unit vector along the x axis. Unit vector means vector having magnitude 1. This will be what? V sin alpha, negative y axis. Final velocity also will do that. Resolve into two components indicated by black ink. This is V cos alpha and this is V sin alpha. V cos alpha, I cap, x axis. This is V sin alpha minus j cap, negative y axis. Right, students? In motion in a plane, vector is being dealt. You will, of course, next year deal it as a chapter fully. It's so many operations, okay? But simple, at least resolving of vectors, you must know this year in physics itself, okay? So, I want to find the change in velocity. Change in velocity is final velocity minus initial. Okay. What is change in velocity? Final velocity minus initial velocity. When you subtract V cos alpha plus sin, minus of minus V cos alpha, minus of minus becomes plus. So V cos alpha plus V cos alpha, 2V cos alpha. And direction is I cap. These two, when you subtract, they are same quantities. If you subtract, it will become 0. So sin components cancel, cos components are added. Clear? Okay. Have you taken down? Should I wait? 1 minute. All right. Clear? Okay, guys. Yes. Okay. Now, what have we found, students? Change in velocity. If velocity changes, what changes? No, correct. What changes? Velocity changes. Momentum changes. If momentum changes, there is external force acting. So now we are connecting to Newton's law, right? Okay, I'll just move on to the slide. Are you ready? Done? Okay, I'm going. Shall we move on? Okay. Ready, guys? Okay, now. Ready? One more, one small change I'm going to make. You need to tell me what will be the difference, okay? Anyways, covering in the PPT, but I want you to learn it here detail right now. Students, are you able to observe? Is there any difference? Yes. This time the angle is with what? Y-axis, not with x-axis, y-axis, right? In such a case, what will happen? Okay, if that angle is theta, what is this angle? Theta, vertically opposite angles. I am resolving this into two components. So now, how will it be? What is the component along y-axis? What is this? V. Come on. Whatever is touching theta will be what? Cos. So it is V cos theta. And what is this? What is this? V sin theta. See, whatever is touching that angle theta, right? That side will be what? Cos. Trigonometry, adjacent side by hypotenuse. Cos theta. Okay, now let's move on to the next, the reflected ball, right? So it's coming along VF. Now VF, you have to resolve it into two components. Now tell me, VF, what is it? V cos theta down, correct. What is here? So tell me now. What is V initial? What is V initial? V sin theta is in which direction, ma? Negative x-axis or positive x-axis? Huh? V sin theta. Green color. Negative. Minus I cap or plus I cap? Minus I cap. Then what else? Very good. Tell me V final, ma. V sin theta plus I cap plus V cos theta minus I cap. Perfect. Now, what are we going to do, guys? Change in velocity. Change in velocity is what? Final minus initial. I subtract the two equations. What will cancel now? Look at it, ma. Minus V cos theta minus of minus V cos theta. What will happen? Minus V cos theta plus V cos theta. They will cancel. Subtract. V sin theta I cap minus of V sin theta minus I cap. So it will become what? V sin theta plus V sin theta I cap 2V sin theta I cap. So this time what will survive? V sin theta will survive. What will die? V cos theta is gone. Now we have found change in velocity. We need to find change in momentum. What is change in momentum? Mass into this. Then that divided by time will be what? Force. Take it down, we'll move to the PPT. In this detail, it is not explained in the PPT. That's why I took to the board. If you learn this properly, you will understand what is there on the PPT. Any doubts in it? Of force, relating force and change in momentum. See here, momentum was on straight line, right? We are only dealing with straight line. We are not dealt with plane, right? In numericals, obviously, you will have such things in your text. Okay, students, now we'll move on. Okay, now we'll review it now in the PowerPoint. Listen. So what is happening? Observe. Everybody please observe. So ball is hitting the surface, getting reflected back. So what is the moment? Change in momentum. Directly it is given a 2 mv cos alpha. But I told you how it comes. Clear? So now suppose if I change. So where is the change in momentum acting along which direction? Along the normal. So changing momentum along the wall is what? That is V sin alpha minus V sin alpha. What is it? 0. So only along the normal there is change in momentum. Let's say the T is the time of contact. What is the expression for force? Force. Second law, Newton's second law. Change. Okay, before that. Change in momentum by time. What is the change in momentum here? What is the change in momentum? 2 mv cos alpha. Therefore, what will be the force? Change in momentum by time. What is the change in momentum? 2 mv cos alpha by t. That's all. Is it clear, guys? How it is 2 mv cos alpha? I took efforts to draw it and show you in detail. Okay. Now, next one you can tell me. You will tell me yourself. Tell me, students, now, what will be the change in momentum? Change in momentum will be what in this case? In previous case, what it was? 2 mv cos alpha. Here it will be 2 mv sin theta. So what will be the force? 2 mv sin theta by t. That's it. So change in momentum is 2 mv sin theta. Obviously, this time also change in momentum is along which direction? Normal. What is the change in momentum along the wall? 0. V cos theta minus V cos theta becomes what? 0. Therefore, change in momentum along the wall is 0. V cos theta minus V cos theta 0. V sin theta minus V sin theta becomes 2V sin theta. So force is equal to what? Come on, quick. 2 mv sin theta by d. How it is 2 mv sin theta? I have drawn it for you. I'm sure you have taken it down. Now let's move on, students. Okay, now whom shall I ask? Okay. Your good name? I said, okay. I said, tell me, ma. Simple question. Which is correct? An average force. Or even you can say, take it as instantaneous force. Take it as instantaneous force. Tell me. Simple. Come on, madam. A good name? No. Tell me, ma. What is force? A is correct. Okay. Good round of applause. Okay. dP by dt. Okay, force is dP by dt. We have been learning from morning. Okay, good. Okay, now next, who is that? Nobody wants to see me now. Okay, get up. Did I ask you before? No. Okay, now tell me, ma. Motion of a particle is described by y is equal to ut plus half gt square. Find the force acting on the particle. MA. Specifically, perfectly for this equation, you should tell me. Okay. Good name? Sanjay, tell me, Sanjay. Good. Okay. It's kind of tricky because of the sign, but a minus mg is, of course, I was expecting mg, but minus mg is more accurate. No problem. Give a good round of applause. I should have avoided that option. Okay, no problem, guys. So the point is, all that you understand is, what is this equation representing? Motion in a straight line. Equation of motion, S is equal to ut plus half at square. It is simple to do it this way. Acceleration is what? G. S is equal to ut plus half at square. How many of you know that equation? I hope everybody. From 9th class you are learning? Huh? Okay, fine. Listen, everybody. S is equal to ut plus half at square. If you first row 100. If you compare this equation with that equation, in place of A, what do you have? Ma? G. Normally, it is not that what answer he gave was wrong. Okay, normally F is equal to what? MA. But here, among the given options, which is best? But A is not there in the equation at all, no? That's why you have to go one step further. So, M in place of A, what do you have? G. So, MG is correct. But his answer also I cannot deny, because what is your logic behind minus MG? Sanjay? Not necessarily freely falling. U is there, right? Why is it freely falling? Falling under gravity. If you say freely falling, then U is 0, right? Free fall. Downwards, therefore minus. That's what you should say. Okay. Correct. No, it is. Okay, students. Okay. Now, here, if somebody is saying minus mg, no problem. Yeah, I understand that. Now, we come from a different space when we say mg is the answer. Okay, I'll tell you how. Little differentiation you understand, then you'll be able to appreciate this. So displacement is given. What is velocity? Differentiation of displacement. Students who know differentiation might be able to answer. What is differentiation of ut? U is constant. U. What is integration of half gt square? What is t square differentiation? ut. So if you cancel, you'll get v is equal to u plus gt. Even if you don't know differentiation, no problem. You can do it using Newton's first law of motion. What is your equation of motion? First one. V is equal to u plus at. So V is equal to u plus at. Directly you can write, in place of A you have G. Acceleration is dV by dt. If you differentiate u plus gt again, remember children, in your first year book, motion in a straight line, NCERT textbook, you have calculus method, differentiation, integration. Only formula you need to know. What is the differentiation of x power n? N into x power n minus. You have to know some formula. That's all. Formula is also given in your physics textbook. What is the differentiation of a constant? 0. Differentiation of x square, 2x. Differentiation of x, louder, 1. Differentiation of x cube, 3x square. Basically one formula, nx power n minus. That's all you need to know. Integration, what is the formula? What is the integration of x power n? X power n plus 1 by n plus 1. Okay, anyways. Right, guys. So acceleration. Now, what is acceleration? You have to differentiate velocity. In a differentiate velocity, u is a constant. You differentiate, what do you get? 0. Gt, you differentiate, what do you get? G is a constant. 5x, what is the differentiation? 5, constant. So you'll get G. So force is equal to m into A or m into G. So from that context, F is equal to mg is correct answer. But even at this point, if you say minus mg, I'm okay with it because you're talking about the direction in which it is acting. Okay? Fine, students. We will move on. Impulse. So we go to the next concept. What is it called? Impulse. What is impulse, students? Come on, quick. Force multiplied by time. Force acting for a small duration of time. And you will understand that that is nothing but change in momentum. Your impulse will be nothing but change in momentum. Anybody wants me to give you the formula for this? Okay, you will look into your text. Okay. So what is impulse? Impulse is product of force and time that produces a finite change in momentum of the body is called impulse. That means a force acts for a very small time. When force acts on a body, what will be there? Acceleration will be there. Because of that, what will be there? Velocity will change. If velocity changes, what changes? Momentum changes. A force acts on a body for a small amount of time, resulting in change in momentum. This is called impulse. Product of force and time that produces a finite change in momentum of the body is called impulse. How is it mathematically given? Okay, before that we understand what it is. Right? Let's say collision of billiards balls. Similarly, right now what we were seeing, right? A ball going and hitting the wall and coming back, right? We saw the change in momentum. Similarly, nail driven into the wall by striking it, correct, with a hammer. See here, the examples that we are choosing are contact is happening for a very short time. The hammer hits the nail. The duration of that force on the nail is very short, but it produces a change in momentum. This is called impulse. A force acting for a very short duration of time. Billiard balls are moving. They are meeting each other only for a few seconds and then going back, correct? What is the unit of impulse? I told you, impulse is what? Force into time. What is force unit? Newton. What is time? Second. So Newton second is the unit. Or in other words, you can say, come on, tell me guys. kg. What is the unit of force? kg made up a second square is the unit of force into time. So 1 second will get cancelled. So we'll get what? kg made up a second. Or it will be same as the units of momentum. What is going to be the dimension, students? m, l, t power minus 1. Why? kg, weight, that is mass, m. Meters, length, l. Second, time. So t power minus 1. So let's move on. So impulse is also a vector quantity, guys. Impulse is a vector. Force is a vector. Acceleration is a vector. Momentum is a vector. CGS system, it is dyne second. SI system, Newton second. Dimension formula for impulse. Quick, tell me. M, L, T power minus 1. Same as momentum. Impulse is a vector quantity whose direction is same as the direction of force. So momentum and impulse have the same dimension, same unit. In fact, impulse is nothing but change in momentum. Let's move on, shall we? Okay, guys. Now, okay. Listen. Observe. Okay. Now don't punch on each other's face. Okay, fine. Impulse and momentum, guys. Force is equal to. What is force? Newton's second law. What does it say? dP by dt. So I can keep dP this side, dt I can take it to the other side. Integrate on both sides. This is very important operation, guys. Throughout physics, you will have this everywhere. Next chapter, work for energy, you will see integration. Next chapter, rotational motion, you will do integration. Is it clear, children? And second year complete, almost every chapter you will do that. Okay, so learn basics of differentiation integration. Very, very important. Okay, just learn the formula and at least what is given in your textbook in your physics, learn that. Okay, so dP is equal to F into dt. dP is nothing but what? Change in momentum. So if you integrate it, you will get change in momentum. So that is integral of T1 to T2 F dt from time 1 to time 2, force and time graph. And anybody knows the geometrical meaning of integration? Louder. What? Area under the curve. You just need to find the area. The simplest way for our, when you are solving physics is, whenever you are asked to find the integration of something, find the area under that graph. That is enough. Okay, so area under the force time graph will give you impulse. Okay, now, see here, there is something called as time average force. Instantaneous force and time average force, like instantaneous velocity, average velocity, like that, right? So when you find the time average force, you will get a rectangle instead of this complete area. It will be an approximation. Don't worry about this part. Forget it right now. Don't worry. Just understand a couple of things. What is force from Newton's second law? Quick. F is equal to dP by dt. Then what is dP? Take it to the other side. F into dt. From dP, if you want to get momentum, what you should do on both sides? The process called integration. It is kind of summation. If you have finite values, you will add them, correct or not? If you have infinite values, you are going to do a process called integration. One more way of understanding it is with its geometrical meaning. Integration of a function will give you what? Area under the graph. If you have the graph, the area under the graph will be given by this operation, what we call as integration. What is the geometrical meaning of differentiation? Slope of the tangent. Excellent. So if you want to find dy by dx or dy by dt or dv by dt, what is dy by dt? What is rate of change of displacement with respect to time? Velocity. Rate of change of velocity with respect to time, dv by dt. Acceleration. It is nothing but if you have velocity time graph, if you want to find acceleration at a point, just draw a tangent, find the slope of it. How do you find the slope of a tangent? Yes, if the line makes an angle theta with x-axis, tan theta is the slope. Okay, guys, little bit of mathematics foundation you have. Okay, of course, you will be learning it later. Correct? In trigonometry, you will learn all these resolutions in the sense about triangle. What is sin theta? At 10th also you have learned. In chapter called straight lines, you will learn what? Slope of a line. M is equal to tan theta. All these things you will learn. But because it is there in application in physics, you have to, at least what is there in the text, that much you should know. Okay. Then dy by dx. What is dy by dx? You will learn next year or probably end of this year in math. Limits and derivatives. But you can't wait till that point. At least little bit you know for solving the problem. Okay. Then what about integration? Again, you will learn it in second year, but don't wait till that point. Right now in your physics textbook, it is given. In your NCERT textbook, it is given. Correct or not? Calculus method is there or not? How many of you have seen it in the textbook? in your official textbook. Yes. So you must go through it. It is there. Fine, guys. So let me repeat again. F is equal to dp by dt. dp is equal to f dt. To get momentum, you need to integrate. Integration means nothing but area under the curve. That is going to give you change in momentum. Change in momentum is called dash. Change in momentum is called what? Impulse. What is change in momentum? Impulse. It is also what? Force into time. Okay, now what is the application of this? Come on, guys. Now you are laughing about this, right? Okay, guys. Now see here, what is happening? Now let's say, have you seen boxing? Yes or no? Okay. Now, is it boxing, guys? Yes. Okay, fine. Now, listen, everybody. What is happening is here, somebody comes and punches you in the boxing ring. What do? You bring your face. Come on, punch me. You do that? Do you do that? What do? Go back. Why? Not just from escaping from the punching, okay? Not just from escaping the punching, but also what? Impact will be reduced, right? If you go forward, what will happen to the impact? Greater impact. But when you move up, still you get the beating, but the impact will be less. Because, why? Why? Tell me, guys. Because in the first case, impulse is more. Second case, impulse is less. I will explain again. That guy is giving the same force. Understood or not? He is giving the same force. But if you go forward, that force is acting on you for a longer time. So effect will be much more. But if you move away, he moves and hits you. What is happening? It's there for a fraction of a second. So impulse is less in the second case. You just observe here, guys, students. Change in momentum is same. If you move forward, time is less. Force is what? Very high. Here, what is happening? You get more time, in the sense impact is less. The time when he is hitting, right, that is less. But that movement time is more, right? So what is happening? Force that you are going to experience is what? Less. So impulse is less. In which case? Second case. The first case, what is going to happen? Impulse is more. Let me give you one more example. You will understand much better. How many of you play cricket? Okay. How many of you watch cricket? How many of you at least have seen what is cricket? You won't ask me how much is cricket, huh? Or what is cricket? You won't ask me, right? Everybody knows what is cricket, right? Okay. Now, listen. Have you seen fielders taking the catch? Okay, today they are today they are different level, okay? But even then, you can understand. Let's say you are in the, let's say Virat Kohli is batting, okay? Now, you've heard of John T. Rhodes, old player. Similarly, probably now Ravindra Jadeja, people, who stand at point, right? So let's say the ball is outside off stump. Virat Kohli goes for a square peg, okay? With great timing and power. Now the ball is coming so fast, okay? Listen. Now the fielder has to catch the ball. What do you think he will do? I'll tell you two options. You tell me what he will do. Coming towards, okay. He catches it. Listen. Yes. At least one thing you can be sure, right? He will definitely not. Yes or no? Immediately his fingers will be fractured. Are you getting my point, guys? When he allows the time, and he's going to catch it, in the product F into T, T is more, right? F is less. So impulse is what? Less. But if you catch it like this, what happens? Time is less. Force is what? Very high. Impulse is very high. It's going to hurt him a lot. Is that clear, guys? Let me keep my remote. Okay, guys. Fine. So if force is constant, then what is impulse dependent on, guys? If F is constant, time. So according to Newton's second law, dp by dt, F into dt is dp. dp is nothing but change in momentum, P2 minus P1. What is P2, ma? All these are known to you. Come on, tell me. F is equal to dp by dt. Take dt that side. So FDT is equal to dp. What is FDT called? Quick impulse. What is delta P? Impulse. So you're integrating it, you get P2 minus P1. What is final momentum? Mass into final velocity minus mass into initial velocity. So that's your impulse. So impulse is nothing but change in momentum. If the force is variable, see here, when force is constant, it is enough to write it like this, mv minus mu, F into dt is enough. But if your force is a variable force, what do you mean by variable force? What do you mean by constant force, guys? Which remains same with time. If force is constant, what is constant? Yes, very good. Acceleration is constant. So whenever acceleration is constant, it is enough to write impulse as what? mv minus mu. But if force is varying, what is the meaning of that? What is varying? Louder. Force is varying. What is varying? Acceleration is varying. Very good. With what? Time. If acceleration is varying with time, the body is undergoing non-uniform accelerated motion. I repeat. So if force is constant, what is constant? F is equal to ma, no? M is constant. M is always constant in all our applications. Acceleration is constant. Good. If F is constant, acceleration is constant. Right? Acceleration is constant means you can simply write it as what? mv minus mu. Change in velocity into mass directly. But if force is changing, that means what is changing? Acceleration is changing. Acceleration is changing means acceleration depends on what? Time. That means what kind of a motion is the body undergoing? Motion in straight line, you've learned. Non-uniform accelerated motion. So that means acceleration will depend on time. That means force will depend on time. There is all your three equations that you have learned will fail. Your V is equal to U plus AT, V square is equal to U square plus 2AS, S is equal to UT plus half AT square. All the three equations are useless. Where? Non-uniform accelerated motion. There is only one way you can do these sums. How? Using calculus. No other go. You have to use integration and differentiation only. But whenever a body is undergoing uniform accelerated motion, all these three equations come to your rescue. They are very, very helpful for you. You don't have to do integration differentiation. Ready-made formula is given for you. You can do it. Right? Okay, now going by the same logic. So when you have a constant force, impulse will be simply m into p minus u. Mass into change in velocity or change in momentum. But if your force is variable, then your momentum cannot be simply obtained. It has to be obtained using integration. And what is integration? If I give you force and time graph, how can you find the integration? Simply find the area. Yeah. So force time graph is there. Area under the curve will give you your change in momentum or impulse. Okay, now final point on impulse at this point. If a force acts on a body for time t1 and another force acts for t2, another force acts for t3, then what is the total change in momentum or total impulse will be nothing but what? Sum of all the impulses. First impulse is F1 into t, second one F2 into T, third one F2, F3 into T. You will add all of them. How will you add them? Not simply 5 plus 3 plus 2. Vectorial addition. You will do what? Vector addition, because force is what? Vector. What is momentum? Vector. What is impulse? Vector. For doing vector addition, you are taught two concepts in motion in a plane. What are they? Triangle law of vectors and what? Parallelogram law of vectors. You may use them to do it. Later you will find out when we solve numericals, you will find out that we can use resolving of vectors. It makes the sum much easier. What we did in the previous session or just in the beginning of the session, you can do so that you can do it better. Anyways, so now we look at applications. Definition is done. Some simple applications. What is it, guys? The person falling on a concrete floor from a certain height receives more injuries than when he falls from the same height on a soil. From some height, you are jumping onto a concrete floor, you will get more injuries compared to, let's say, from the same height, you are jumping onto the sand in the beach. Why? Because when you jump, you get more time. Force is less on you, impact is less, impulse is less. But here, when you fall, the floor doesn't go down, correct or not? So time is very short when you hit the ground. So it is what? Impulse is more, effect is more. Next. Shock absorbers are used in vehicles to reduce the magnitude of impulsive force. Same concept. When you jump into a soil, what happens? You don't get hurt so much from the same height. Same thing is the functioning of your shock absorber in your vehicles, right? If shock absorber is weak, what happens? You get more impact, correct? Because less impulse when you have good shock absorber. Okay, now cricketer, what does he do? Lowers his hand when he takes a catch. Even if he takes like this, he'll go back, not forward, correct? Even if you have to dive and take the catch, don't go like this and take it. You go as low as possible. Are you able to understand, ma'am? Okay, who next now? Whom I have not asked. Yes. Yes, Arshita. Come on, simple. What is impulse? Shh. Get up, get up. What is your name? Anita, tell me, impulse. Impulse. Huh? Force into time, that's all. Option A you told, okay, I told. Good, sit down, sir. Understood, Chita? What is impulse? Force into time, or in other words, what is impulse? Change in momentum. Very good, very good, very good. Okay. That's correct. Very good. Next. 5 minutes. Okay, now. Who else? Darwin, get up. What is the dimensional formula for impulse? -1. You good round of applause? Okay. So, I'll ask one more question which is not there on the board. Okay, can you try? Okay. Dimensional formula for impulse is ml_t power -1, okay? Which other physical quantity has the same dimension? I didn't start also. I will repeat. The answer for this is known, ma. Answer is third option, okay? For impulse, the dimensional formula is ml_t power -1. There is one more physical quantity which has the same dimension. What is it? How? Okay, guys, no problem. Sit down. Yes, Sanjay, can you explain? Momentum, right? Why? What is impulse definition? Yeah, not rate of change. Change in momentum. Rate of change of momentum is force. Right? Good, good, good. Very good. Okay. Okay, students. Okay. Time running. Okay, good. What is the dimensional formula for impulse? MLT per minus 1. What is the one quantity which has the same momentum? What is impulse? Force into time. Otherwise, change in momentum. That's all. Cricketer lowers his hand while. Okay. Nobody answer now. I'll ask somebody. Yes, saying. A cricketer lowers his hand while catching the ball is an example for impulse, momentum, force, both B and C. Yes? Impulse is correct. You don't have applause. Okay. I'm happy. Okay, guys. Fine. What's the time now? Almost. Fine, guys. I think third law of motion, I think we are going to conclude by 12:15, I guess. Am I right? 12:15, we're concluding. Just give me a minute, guys. I'll talk to you and then we'll close.